So vertical stripes, if it's just X, so that should be able to at least narrow down a couple of them. Like, oh, these are the ones that are just X, and then you can kind of distinguish based on the formula. If they are X and Y, I would look for, so if it's both X and Y, look for where the slope should be 0 or undefined. So wherever the slope should be 0 or should be undefined, that will help you to figure out like, oh, whenever Y is 0, my slope should be 0. And then you can look at your different options and see. Okay, do you guys have any questions on slope fields? Okay, so there's kind of two problems here. One where you'll be creating your own, and then one that's going to be a matching section. You'll have 4 equations and pictures. Okay. Questions on this? Questions on the outline? Any specifics here? Okay. Did anyone start on the review assignment and have a question or two? Yeah.
Are you guys designed with the half-life zones for like the percentage problem?
Yes. Yeah. So that's because without that you wouldn't have enough information. There was a problem in the review assignment, and there was also one in the in-class assignment that was about carbon dating, and you needed to know K, and like they had that in the notes, but you'd have enough information right on the test to solve for C and for K. Other questions? Yeah.
Did you do 23?
23, yeah, do you know which page that was?
That was 533.
Okay, so page 534, you said number 23? Okay, so this one is a separable differential equation. So it starts with this. It's got y minus y1 times y prime is equal to t. So we start by separating, differentiating. They give us an initial condition where if we plug in if we plug in +1, we get -3. So the separating step is pretty much done already, except this y prime would be a dy by dt, so we can move the dt over to the other side. So the dy stays here, and then the dt moves to the other side. So that's the separate step. Then we integrate on the left-hand side, so don't get thrown off. Don't think that the y minus 1 has to be integrated as an entire set. Like just use y and 1 and integrate them separately. So this would be 1/2 y to the second. This would be minus y. Okay, I see where the problem is here because there's 2 y's. Yes, this is some weird algebra to get y by itself. Equals, and then this would be a 1/2 t squared. Put your plus c on the right-hand side. So the algebra that you guys are going to have on the test is algebra that you have seen before, like natural log or E or something like that. This, I'm going to walk through it because it's interesting, but you won't have to do anything like this on the test. So I would start by clearing out this 1/2 and at least getting this to be a y squared. So multiply every term by 2 and you will get y squared minus 2y. This will be a t squared, and then this is the one and only thing that doesn't need to change because the 2 would distribute to the c, and 2c is still just an arbitrary constant. So then this is actually, I'm a little bit mad at myself for assigning this to you. This is completing the square to get the y in just one spot. Like, do you guys remember when you'd be able to write it as like y minus something squared? So do you remember taking this middle number, you cut it in half, and then square it? Is this sounding familiar at all? Okay, so you cut the -2 in half, you get -1. Square that, you get 1. So we would write y squared minus 2y plus 1. And then we'd have t squared plus 1 plus c. This is going to become kind of a weird thing too, because like 1 plus c, still just an arbitrary constant on the right-hand side. And then this is now just y minus 1 squared. So now the y is effectively just in one place, and we'll be able to solve for it. On the right-hand side, I'm just going to put t squared plus c because 1 plus c is still just an arbitrary constant. So then we are going to take the square root of both sides to get the y by itself. Remember when you do that, bless you, to put a plus or minus, and you can actually see up here that the y value is negative. So they're going to end up using the negative value, but we'll get there once we do the initial condition. So start with a plus or minus. This time the c is affected because square roots do not distribute. Like it wouldn't be the same as the square root of t squared plus the square root of c, even though it's tempting to want to do that. And then add 1, the 1 would be on the outside when we get the y by itself. So then sub in the initial condition, it says when we sub in 1, we end up getting -3. So -3 goes in for y. We still don't know yet whether it's the plus or minus. Sub in 1 for t. And we have this plus 1 on the outside. So subtract the 1 first. And then square both sides of the equation. So even when we square the left-hand side, it still comes out as a positive 16. So we end up getting a value of c equals 15. Subbing that back into the initial, I'm going to talk about the plus or minus. Okay, so for the initial condition, this tells me when I sub in 1, I'm supposed to get -3. So when I sub in 1, 1 squared would be 1, plus 15 would be 16. Square root of 16 is either plus or minus 4. So this comes out to be either 4 plus 1 or -4 plus 1, and we need it to be -4 plus 1 to make sure we get the right initial condition. So our actual equation would be the negative square root of t squared plus 15 plus 1 on the outside. So like the specific algebra of needing to know how to complete the square, you're not going to need to know that for tomorrow. But the rest of it, the solving for c, the integrating, all that stuff, you definitely need to know how to do. Any other review questions? Yeah. Same page? Or same like set of problems here? Okay. Yeah, so... Yeah, and this one doesn't have an initial condition, so we solve it by separating. So this, you would have to add the y first. You can't have like something plus dy or something plus dx. It's just times, you know, like x dx. You'd never see x plus dx, or you wouldn't be able to integrate that. So you'd have to start by moving the y over to the other side. So you'd have x dy by dx is equal to 1 plus y. So what ends up happening here is you have to treat that 1 plus y as an entire quantity to divide it back over to the other side. So this, like the x is going to swap over, they're both going to swap over. So we have 1 over 1 plus y with the dy, and then the x gets divided over to the right, and the dx moves over to the right as well. So that part gets a little tricky because you can't like subtract the y back over. Otherwise, you're right back where you started. So in the first step, you add or subtract if you need to, just to make sure that everything's separated correctly. But once you start the official separating, you can only separate by multiplication or division. You cannot separate using addition or subtraction, with the exception of like a first step that looks like that. So now we've got everything separated, because you can only multiply by dy. You can't have like y plus dy, like I said. So then we integrate. Both of these sides are going to be natural log, because they're both just negative first powers. This, you could use a u substitution, but you don't technically need one because this guy's derivative is just 1. So this would be natural log of the absolute value of 1 plus y. This right-hand side would be natural log of the absolute value of x, and then plus c. So we would exponentiate both sides. The left-hand side will give us the absolute value of 1 plus y. The right-hand side, just to remind you guys, we split this into e to the natural log of the absolute value of x times e to the c, just doing like a little reverse of that exponent rule. So the left-hand side is still absolute value of 1 plus y. On the right-hand side, what we end up with is this. We have c times the absolute value of x. The e to the c is just an arbitrary constant. It's not equal to c, but c is just a representation. E to the natural log of the absolute value of x. The e and the natural log are inverses of each other, so all you would have left is the absolute value of x. The next part that throws people off is when you drop these absolute values, you make the right-hand side plus or minus, it doesn't drop the absolute values around the x. The absolute values would still be around the x in this scenario. Because let's say, let me give you a for instance here. So say you had like absolute value of y is equal to the absolute value of x. That does not mean that y is equal to x. Because like you could have a negative number on one side and a positive number on the other side, so you can't just equally drop the absolute values. You'd still have to have a plus or minus somewhere. So this we have just a 1 plus y on the lefts. Technically, it's because we have a plus or minus in front of our c. You don't have to have that in your final answer because it still just represents an arbitrary constant. And I would just subtract the 1 over to the other side. You get that. Okay, any questions on that one? Okay, so I don't have time for another full problem, but does anyone have just general questions about anything? Yes?
Can you give us the answers to 98 and number 12?
Oh, yeah, I can pull those out.